Good morning, everyone. Now we are going to discuss angles and the unit circle. Let's start at the beginning here if I want to draw any angle in the world. So we need to know some basic concepts here. We need to know that there are some positive angles and there are some negative angles. But all of us in the world, we have to graph it in the same way. That means you and me, whenever we graph an angle, so we need to know from where we have to start. All of us here, we have to draw angles in standard position. We have to draw any angle in standard position. Okay, this is the first part, standard position. So what are the conditions for standard positions or standard position angle? We have here two conditions. First of all, the vertex at the origin. The vertex at the origin. Okay, this is the first part. And the second part here is what? Vertex at the origin. Second part here, that the initial side on the positive x-axis, initial side, okay, on the positive x-axis. Positive x-axis. And always here, if you just still remember, positive x-axis. Okay, and if you just want to remind yourself here, how can I draw any angle? Here I have those two legs, right? And this is my vertex. This is my vertex, and this is the leg, and the other one here, this one we call it leg. So we are going to call it now initial side instead. We're going to call it now initial side, and this is the terminal side. Here, if I rotate up like this, so this one is the terminal side. This is the terminal side. Okay. So here, always we are going to draw any angle in standard position. So this is my vertex at the origin. And here, this is my initial side. Always we are going to draw using this positive x-axis. Then, for example, if I ask you to draw angle that measures positive, let's say 65. So we are going to use the protractor and rotate here. So it's going to be something like this. We will rotate up. Why did we rotate up? Because it's a positive angle. So then we will draw here 65 degrees. If it's positive, so that means we will go up. If it's negative, that means we will go down. Okay, so here I have positive angles and negative angles also. So this is positive as it's positive angle. So that means we will go up from the initial side, positive angle. And also here, if I have negative angle, negative here, so that means we have to go down. Okay, negative angle. Let's have more examples. Let me add here one more slide. So for example, here, if I want to draw, let's say here I want to draw, those are my axes. Let's say that I want to draw now, okay? And I want to draw, for example, 130. So how can I graph 130 degrees? Again, we are going to start vertex at the origin, initial side on the positive x-axis, then rotate up or down, up. Why? Because it's positive. So we will rotate up. Till this point here, we have 90 degrees. Till this point here, we have 90 degrees. Then move on a little bit until you reach to 130 degrees using your protractor. So this is 130 degrees. We are going to call this one. This is the first quadrant. This is the second quadrant. This is the third quadrant. And the last one here will be the fourth quadrant. Okay. Here also I have, let's say that I want to draw something else, something like negative 50. Okay, something like negative 50. Can you expect in which quadrant we will be? Yes, excellent. So see again, vertex at the origin, initial side on the positive x-axis. Go up or down from the initial side? Down, excellent, till this point. Pay attention, this is 90. So we will move till 50 approximately. Then here, this is my terminal side. Pay attention from the rotation. Here we went down because it's a negative angle. Let's have the last example. I mean, within this idea, let's have this idea, this last example. If I ask you to graph 210, I mean positive one, 210. So Again, vertex at the origin, initial side on the positive x-axis, then rotate. Rotate until you finish 210. Till this point, you finished 90, okay? Till this point, you finished 90. Continue here. This is 90, 180, then till this point, I have 210. So we will be in the third quadrant. Okay, so now we've learned that I have here positive angle. If we have positive angle, so that means we will start from the positive initial positive x-axis, which is this one. Then we will rotate up. If we have, that means here we will rotate up. And if it's negative angle, so that means we will rotate down. Excellent. Okay, let me move on. If I give you this example, for example, if I give you, or if I ask you now to graph, let's say, here I want from you to graph 135. Okay, 135 degrees. Okay, and also I want from you to graph 200. 225. Okay, 225. Okay, so I want from you to draw those two angles. So how can I graph here 200? I mean, I want this one to be 200. I want it to be negative. Okay, only I want just to be negative. Okay, so let's start. Yes, let's start here. I want it to be negative. Let's see. How can I graph them? Please try to examine yourself, hold the pencil and try to solve it alone. Here, this is 135. So we are going to start from this point again, vertex at the origin. Then this is initial side, rotate 135. We are going to stop in the second quadrant, right? In the second quadrant. Now, again, I want to draw negative 225. So how can I graph it? Again, vertex at the origin, initial side on the positive x-axis, rotate. Here I have 120, 180, then 225, exactly on the same terminal side, which is the thing that we will call it coterminal angle. So what's the meaning of coterminal angle? That means coterminal angles. That means the angle that shares the same, or angle here share the same, sorry, here, angle. So angle share the same terminal side, share the same terminal side. As all here, same terminal side. As all of the angles are sharing the same initial side. All of them, we have to start terminal side. All of them here, you have to start from the positive x-axis, and we will rotate either up or down. It depends on the given angle. So this is the second thing that we have to know, coterminal angle. Okay, let's have let's have one more example. He told you, can you graph here, if I have this point, I want to find out what are, here I want to find out in this one, in this example, he asks you to find what is the measure of the angle which is shown. Let's have this example. Let me write it here for you. Okay. Yes, good, brilliant. Yes, so see here, what do I have? This is my angle. It's an example, okay? And he said, what is the measurement of the angle that is shown here in this, yes. So see here, what do I have? He gave you this point, okay? And what was the point that he gave it to you? -4 and 4 radical 3. -4 and 4 radical 3. For example. Okay, so how can I solve this one? First of all, I want to know, this is my vertex and this is my initial side. Rotate and I reach it to this part. I want to know, how can I use trigonometric functions now? So what are we going to do? We are going to create a right triangle. The vertical distance here is y, right? And the horizontal distance here is x. What is given here? This is point, this is x and this is y, right? This is x and this is y. So what is y here? Y equals 4 radical 3. And what is x here? X here equals negative 4. If we will take this, if you just to remember, here this is 4, this is 4, and this is 4 radical 3. If I will take my triangle here, I have this is 4 radical 3, and this is 4. I mean negative, just ignore the negative sign for a while, but we want just a distance. So can you predict here what kind of triangle this one? Excellent, you've got it. So that means here, the one that faces X, you can't just predict it. The one that faces X here, this is 30, excellent, special triangle. And the one that faces X radical 3, this is 60, excellent. So that means the angle which is here is what? 60 degrees. And how can I get this one, the red one? So we are going to say here 180 degrees minus 60 equals 120. Excellent. Okay, let me give you another example. Just to emphasize, yeah, this is my example, sorry. Okay, let me give you another example here. Okay, this is my example. Another here example also. What do I have here? I have this side. Okay, have a look here. If I ask you, see, again, we are going to start from this point and we are going to rotate until we reach this point. What do I have here? What is this point? Let's say that it's 5, radical 3, and 5. Okay. So how can I get this angle? What shall I do first? So here, what shall I do? First of all, we are going to create our right angle. The vertical distance represent y. Excellent. So this is x here and this is y. What is y here? It's 5. What is x here? It's 5 radical 3. Clear? 5 radical 3. The angle that faces x is what? Excellent, 30. And the angle that faces 5 radical 3, x radical 3, so this is 60. Brilliant. So that means how can I get this angle, the required angle? So I mean the red one, red angle. How can I get it? Excellent. So I need to get here 180 degrees plus 30 degrees equals here 210. Okay, one more example to make sure that you've got the idea. One more example here. Yes. So see here, what do I have? Okay. Imagine that I have this kind of triangle. And here only we need to add negative, negative. It doesn't matter. It's none of our business. Yes. Okay. So here, let's say that I'm here. We are going to start again with the same point. Let's say that this point here is, let's say here it's negative 6. Sorry, it's positive here. In this quadrant, it's positive. Okay, so here is going to be positive 6 and negative 6. Okay, positive 6 and negative 6. How can I get this angle? Find the measure of the angle. How can I get this? Find the measurement here of the angle. So how can I get of the angle? So how can I get this angle? Tell me. Yes, excellent. So first of all, we will create the right angle. The vertical distance represent y, which is here negative 6. And the horizontal distance represent x, which is here 6, right? As long as those are equivalent, so that means this one is what? 45. I've got it. Excellent. So this one, it's 45 degrees. So what shall I do here? How can I get this angle, the red one? So we are going to say 360 degrees minus 45 degrees equals 315. Excellent. I hope it's clear for now. Let me move on for another idea. The only thing here that I want from you to pay attention from it, that's why here we've got that mistake when we just wrote, we forgot the negative signs, but it's fine. It didn't affect on our answer, finally, I mean, but generally you have to pay attention. Okay. So let's see here. I have this. Generally, we have this. Those are my axes. If I ask you about the measurement of the angle of each, so here it will be what? 0 exam. So we are going to start from this point, and this is my initial side, as we said before. So this is my initial side. So this is 0. Okay, this is 0 degrees. Rotate, you will be up here. What is this one? Excellent. This one here is what? 90 degrees. And this one, 180 degrees. And this one, 270 degrees. And finally, here again, we came back to what? 360 degrees. Then you are going to add 90 degrees at each single time. So here, if you rotate from this side, this is 90, 180, 270, 360. Then again, you are going to add 90 again and again. So here we have what? One full rotation for each. So that means we are repeating the same values. Okay, brilliant. We said also here, this is a first quadrant. Here, this is second quadrant. This is third quadrant. And finally, this is the fourth quadrant. If we draw here a circle, unit circle, if we draw here a unit circle, what's the meaning of unit circle? That means the length of the radius is only one unit circle. That means circle. That means R here equals 1. Okay, so this is here R equals 1. R equals 1. So what is the coordinate for this point generally? Excellent. It's X and Y. How can I get X and Y? Here I have, this is my initial sign, and I want to find out, or we've known that this is theta, and this is here X and Y. Let's create our right triangle. What do I have? The vertical distance here represent Y. The horizontal distance here represent X. Excellent. Let's figure out together. What is cosine theta? Where is theta? Here, this is my theta. Cosine, it's adjacent over hypotenuse. Your adjacent here is x over r, but r here in the unit circle, r in the unit circle equals 1 in the unit circle. So that means cosine theta equals x. Excellent. Okay, and we said here sine theta opposite over hypotenuse, so y over r. Since r here equals 1, so y equals sine theta. So sine theta equals y. Okay, so that means we will be able to erase x and y and write the new values for x and y. Instead of x, we will have cosine theta. Instead of y, we will write sine theta. Right? See how it's amazing? So as you can see, instead of x, we have cosine. Instead of y, we proved it. So it's applicable for all. But in the unit circle, what are the coordinates here for each? The coordinates here is what? 1, 0. The coordinate here is what? 0, 1. Excellent. 0, 1. The coordinate here is what? -1 and 0. And the coordinate here is what? 0 and -1. We said here x and y equals to cosine theta and sine theta. So that means if I ask you here for 1 and 0, if I ask you for cosine 0 degrees equals what? Based on this, equals 1, excellent. And sine 0 equals what? 0, excellent. Sine 0 equals 0. Continue here. This is in what? In the first point. Continue here. I have what? Cosine 90. Excellent, because the angle here is what? 90, as we wrote up. Cosine 90 degrees equals 0. Excellent, 0, which is this one. And sine 90 equals 1. Continue here for 180 till this point. So cosine 180 degrees equals -1, and sine 180 equals 0. Okay, and finally here for cosine 270 degrees equals 0, but sine 270 degrees equals -1. If you are going to come back here and you are going to ask yourself cosine 360 degrees equal 1 and sine 360 degrees equals 0. Okay? I hope it's clear for you. You have to memorize those ones till this moment. Then later on, we are going to continue or more. We will get more details in the unit circle. See you soon. Thank you.